Welcome back. In this video, we're going to go over section 6.4, which is about special products. In the last section, we saw how to multiply polynomials, and you can actually multiply any polynomials you want using the methods of the last section. What we're learning in this section is how we can take advantage of certain special patterns that occur that can make our multiplication, if not easier, at least a little faster. So let's take a look at some special products. So let's first multiply x plus 7 squared, kind of the traditional way that we ordinarily would. That's x plus 7 times x plus 7. I'm going to use the FOIL method for this because a lot of students like that. So firsts here will be x squared. That's the firsts out of each pair. Then the outers are 7 times x, and the inners are also 7 times x. So on this special form, because the two polynomials are the same, you'll notice that the outers and inners ended up being both 7x. And then finally, the last 7 times 7 is 49. Combining like terms in the middle, we'll have x squared plus 14x plus 49. Okay, taking a look, there's a little bit of a pattern we can observe here. 14 in the middle, half of 14 is 7, and 7 times 7 is 49. Let's take a look at the next one. X minus 4 squared is the same as x minus 4 times x minus 4. Again, with FOIL if you like. That'll be x squared for the firsts, minus 4x for the outers, minus another 4x for the inners, and then finally plus 16 for the lasts. So this will give us x squared minus 8x plus 16. So again, here, the number next to the x is a negative 8. Half of negative 8 is negative 4. If you take negative 4 and square that, you get 16. So that's a pattern. Let's see if we can try that just 2 more times just to be sure that it plays out as we expect. So let's go with v plus 11 times v plus 11. Here, if we use FOIL, we'll have v squared, 11v for the outers, and 11v for the inners, and then 11 times 11 is 121. V squared, 11 plus 11, 22 v's. Okay, again, notice that half of 22 is 11, and 11 times 11 is 121. And one last one, this one again with a negative. Let's make c minus 20. C minus 20. Okay, c times c is c squared, minus c times 20 is minus 20c. That's the outers. Inners minus another 20c. Then finally, for the last 20 times 20 is 100. So we'll have c squared minus 40c plus 400. Okay, so again, half of 40 is going to be 20, and then 20 times 20 gives 400. So this leads us to the binomial squares pattern. So taking a look from left to right, if we have in the first row a plus b squared, we'll have a squared, that is the first one squared, plus twice the product of the two things, and then finally the last one, b squared. The only difference between the first row and second row is the minus sign. We have either a plus b or a minus b, and that first sign is either plus or minus. Notice in the back that it's always plus. So it's either a squared plus 2ab or a squared minus 2ab. Okay, another thing worth noting is that there's, you can't just kind of quote, distribute the exponent, unquote, to this thing. A plus b squared is not the same as a squared plus b squared. A little numerical example that will illustrate that goes like this. 3 plus 1 is 4. 4 squared is 16. If I tried to use this kind of non-rule, 3 squared plus 1 squared would be 9 plus 1 or 10. And 10 and 16 are not the same. So those two are not equal to each other. Okay, let's try to use this special pattern to help us do a couple of multiplications. Here, w plus 9 squared will be the first one squared, Middle is a plus, so we'll have plus 2 times 9w plus 9 times 9 is 81. W squared plus 18w plus 80. X minus 5 squared will be x squared minus 10x plus 25. First one squared in the front, second one squared in the back. In the middle, minus 2 times the product of the two things. Okay, here are two for you to try. Take a minute and pause the video, try both of these, and then restart the video and see how you did. There's the two formulas. Okay, so let's see how these go. For the first one, we have 6x plus 3 squared. So the front will be 6x squared. In the back, we'll have 3 squared. In the middle, we'll have plus twice the product of the two things. Here, the two things are the 6x and the 3. So this will be 36x squared. 2 times 6 is 12, times 3 is 36. So 36x plus a 9 in the back. Here, we have 2c minus d squared. So for the first one squared, we'll have 4c squared. Then minus twice the product of the two things. The two things. All right, sorry about that. Zoom decided to crash once again. All right, so here we have 4c squared minus 4cd, and then finally in the back, just d squared. All right, so there's our perfect square trinomial formulas, along with some examples. As I'd said, you're welcome to just continue doing multiplication the way we did in the last section, but being able to recognize these patterns can make it a little easier for you, faster at least, to do some of these multiplications. Okay, so let's try just one more, and then we'll go on to the difference of squares formula. So here we have 2x squared plus 1, and that is being squared. So in the front, we'll have 4x to the 4th power. That's what you get if you take x squared and square it, plus 2 times 2x squared and 1. So that's going to be 4x squared. And then finally in the back, a 1. Okay. All right, so then the next thing, we're going to need the idea of a conjugate before to go on for the next item. So if you have two expressions, call them A and B, if you have A minus B and A plus B, those expressions are called conjugates of each other. Or to say that another way, A minus B's conjugate is A plus B, or the conjugate of A plus B is A minus B. They have the same thing in the front, same thing in the back, but one's minus and one's plus. So just to practice at finding a conjugate, the conjugate of x minus 7 would be x plus 7. The conjugate of 3x plus 11 is 3x minus 11. Same thing in the front, same thing in the back, just instead of plus, we'd make a minus. Here, negative 1/4 x plus 0.3. I tried to make that harder. Negative 1/4 x minus 0.3. So in this case, I gave you ones where one was already a negative, so its conjugate had a plus in between. The next two had a plus in between, and so the conjugate had a minus in between. It'll always be the same front thing, same back thing, but one will have a minus, one will have a plus. Okay. All right, so let's multiply together these two, 3x plus 4 times 3x minus 4. You'll notice on these that these two are conjugates. They both have a 3x in the front and a 4 in the back, but one's plus and one's minus. Notice what happens when we try to multiply these out using FOIL. In the front, we'll have 3x squared. That's the firsts. And then minus, we'll have 4 times 3x. That's the outers. Then inners, plus 4 times 3x. And then finally, the last, minus 4 times 4, or 16. So simplifying just a little, you'll have 9x squared minus 12x plus 12x minus 16. That minus 12x and plus 12x, those two together add up to 0. So overall, you have 9x squared minus 16. It turns out when you multiply together two binomials together and their conjugates, they'll always have that happen where the outers and inners from FOIL always end up adding up to 0. Let's try one more. Let's say that we had 5k plus 11 and 5k minus 11. Okay, the fronts are 5k times 5k, which is 25k squared. For the outers, we'll have minus 55k. For the inners, plus 55k. And then in the back, minus 121. So you'll notice again that those outer and inners together add up to 0. And you're left with 25k squared minus 121. Okay, that's the product of conjugates pattern. This one also sometimes called the difference of squares. Okay, and so if you take a plus b times a minus b, you're going to get a squared minus b squared. Just two terms separated by a minus, and both of those two terms are squared, which is why it's called the difference of squares pattern, or the product of conjugates pattern. Okay, so let's try this one. We have 7x plus 1 times 7x minus 1. That will give us 49x squared minus 1. Okay, so here you'll notice that the plus 7x minus 7x, had we done this the long way, those would have added up to 0. So it works out rather nice. Okay, so we just have a few more examples. X minus 5 times x plus 5, that will be x squared minus 25. Since we have the time, I'm going to go ahead and show what the steps would look like. This one would have had we done it using FOIL, it would have had a minus 5x and a plus 5x in it, and those two would have added up to 0. Okay, down here, we have 2x plus 5 times 2x minus 5. The 2x's times each other give 4x squared. Then the outers and inners are going to go away again, and we'll have minus 25 in the back. You'll notice on this one that it always ends with a minus. Okay, 3 plus 4y times 3 minus 4y. That will be 9 minus 16y squared. Don't be put off on this one that the variable is in the back. It still works the same way. First one squared minus the second one squared. In this one, the powers are higher, but that's okay. It's still going to work the same way. We'll have 3x squared times 3x squared. And then, again, the outers and inners are guaranteed to go away. Then we'll have minus 4y cubed squared. That'll be 9x to the 4th power minus 16y to the 6th power. And that will do it. Again, you can do all of this multiplication the way we did it in the previous section, but being able to recognize these special forms can help you do some of this quicker. Also, when we go on to do the opposite operation, which is factoring, it's going to be kind of really necessary to be able to work backwards. So using these patterns is going to be kind of more essential at that time. In the meantime, we finished up section 6.4. Basically, it boiled down to using 3 formulas. Let me know if you have any questions, and then have a great day.